Welcome everyone to the first webinar of the year in our series of short LoadRunner webinars. My name is Anders Nilsson and I'm the Technical Account Manager for LoadRunner Cloud and LoadRunner Enterprise on SaaS. And we are here in today's webinar going to look at how to shift left and scale with LoadRunner Developer. If we start with some background. So a long time ago, hopefully, performance testing was something that was done more toward the end of a software development lifecycle, once all development had finished, and sometimes even after that the application had been deployed to production, leaving very little time for fixing any issues that would actually show up during the testing. Then, over time, people and organizations have realized that the earlier that we can identify and catch any performance issues, we can then usually also fix them before they become more significant or more expensive problems further down the line. This has now resulted in a thinking that not only should just the testers do the testing, but anyone involved in the development lifecycle who can test should also test. So by shifting testing to the left or earlier in the lifecycle has led us to what we now call performance engineering. So performance engineering is a proactive and continuous approach that aims to make sure that all steps of the software development lifecycle are done with non-functional requirements in mind as well, meaning that performance is taken into account during the requirements and the design phase of a product. It's part of the development phase, and it's certainly part of the official performance testing and so on. So by shifting left and making testing and performance testing part of all the activities in the lifecycle, we are then able to mitigate issues that perhaps won't be found until later on. And by catching these issues early on, before they become major issues, that will avoid both delays and increased cost for everyone involved. And before I start talking about how we can shift left, for those who don't know, LoadRunner Developer is a free, standalone and lightweight tool which is built for developers or basically anyone spending a lot of time in an IDE. And it's there to assist them to shift left their performance testing. And that's done by allowing them to create scripts, model scenarios, run tests, and even quickly analyze the results of a test without leaving the familiarity of their own IDE of choice, saving them the effort from having to learn another tool. And LoadRunner Developer is a cross-platform solution and can be used on Linux, Windows, and Mac OS. And as mentioned, it integrates with many different IDEs like IntelliJ or Visual Studio Code, for example. It's free for local execution with up to 50 concurrent virtual users, but that can be scaled up to run a lot larger tests with a LoadRunner Cloud or LoadRunner Enterprise license, still without leaving the IDE, which I will show later on in the demo here. And finally, the scripting is done using a JavaScript SDK, and seeing that JavaScript is one of the most common programming languages used within development today, there is a high probability that you, as a developer, is already familiar with the language. If I now would be a developer, how can then a tool like this help me to shift left? With LoadRunner Developer, I can create tests that can be integrated into my existing testing frameworks, enabling me to create performance tests that can be run in parallel with my other tests, which will allow me to catch and identify performance issues early on. And if I include performance testing into my existing frameworks, I also get faster feedback on any new builds of the application and on any issues that might occur, allowing me to adjust and fix such issues more quickly, so that I can then move on to other development tasks, knowing that the product I'm building is stable. But not only that, by shifting left, it will also improve the collaboration between me and my developer peers, and also with other testers, since by involving performance testing early on in the development process, we can then work together as a team to identify and address any performance issues that might occur in a more collaborative and efficient manner. And of course, by finding and fixing issues early on, that will also improve the overall quality of the application that I'm building, making sure it delivers a higher performance and a better user experience. And finally, if we can catch many issues early on in the development lifecycle, as an organization, we can avoid costly and time-consuming rework later on, allowing us to focus on delivering high-quality software applications more efficiently. How do I then go about to integrate LoadRunner Developer into my IDE? It's a simple download from the Micro Focus Marketplace. Just search for LoadRunner Developer, download the zip file for your operating system, and then extract the zip file onto your local machine. Then on my local machine, I created a folder named devweb in the root where I extracted the downloaded zip file, and I then created another directory named scripts in the root as well, where my scripts will reside, into which I also copied the relevant template files for the IDE. This is all described in detail in the online help, of course, but once done, you're then ready to utilize LoadRunner Developer from your IDE of choice. If I now go to my IDE here, for which I'm using Visual Studio Code, but many other IDEs are supported as well. And if we look at the available tasks that are built into the IDE, before we integrate with LoadRunner Developer, we have no additional LoadRunner Developer tasks here that can be used for our testing purposes. So to integrate LoadRunner Developer into our IDE, we simply need to copy a couple of template files into our script directory from the VS Code template that's available on the marketplace. And if I open a directory that has those files in it, I then have access to the LoadRunner Developer related tasks, as we can see here. So if I would like to start to add some testing to my work, my first task would normally be to create or record a script that would act as a performance test against the application that I'm currently working on. And such scripts are generated from H-archive files. And these can be exported from other tools such as UFT Developer, if we would be using such tools for our functional testing. I can also use, for example, the developer tools in a browser, where I basically just record a flow here and then export an H-archive file at the end of that flow. Or I can use other tools like Fiddler to record an H-archive file as well. But as a developer, I prefer to do such tasks directly from my IDE. So if I would be working on an application, and let's say that I just added a new functionality to that application, I could then record a script utilizing that functionality and then run a quick smoke test against it. So LoadRunner Developer allows me to run up to 50 virtual users locally from the IDE here for free. And by doing so, I could then hopefully catch a performance defect early on in the development before we cause issues further down the line. So let me now quickly create a script here. So I go to Run Task, and then I select Record Flow. And that will then open up a browser to me. So I go to my site here. And let's say that I've add an about page to this site here. Nothing complicated, of course, since this is just a quick demo. And by doing this from the IDE, that will then make use of the proxy recorder that comes with LoadRunner Developer, which you can also use as standalone if needed. And all of that is outlined in the online help. So I'm just going to record a quick business flow here. So I go to the about page, I let that load, and then I go back home again. And then I close my browser again. So this short recording has now generated a H-archive file, which then contains all the actions I did here. And to generate a script from that, I then go to and run a task called generate script here. And once done, I have a full script here covering what I've just done in my business process. And I can then further modify and enhance the script according to the needs of the business process. And all of this is done in JavaScript, of course. My next step would then be to add some transactions to the script, just to be able to measure the different steps that I did in the application during the recording. So I'm adding 2 new transactions here, one for the loading of the front page, and one for loading the about page that I'm interested in. And then I basically just start the first front page transaction. Then further down in the script, I just stop the transaction here. And then I start my about page transaction. And then after that, I just stop that one as well. And then to verify that the script and the transactions works as expected, I can then run a single virtual user. Running a single virtual user is basically done to make sure that all is as it should, that the script works and that the transactions are registered okay. And once the script has run through here, we can look at the results and we can see that the transactions are indeed registered, and we can see my about page transaction here. Having passed that initial test, I'm now keen to see how this application and my newly added about page will handle a couple of concurrent virtual users accessing the site. And to configure that, I access the scenario.yaml file, where I then define how many virtual users that I would like to run this test with, plus any load profile that I would like to have, such as duration and pacing. And once configured, I can then run another test again, this time a load test with a couple of concurrent virtual users. This will then run my virtual users for the duration that I set to the scenario, and once finished, again, I get the measurements and the transaction timings. And I can now see that I do get some minor variation in accessing the about page here. If I would have run a more involved or complex script, it might be that I need access to the log files from the virtual users, since they contain the records of each of the different virtual users that are running in the test. And I can access those from the IDE here as well under results and then log files. And here I then have access to the logs from all the 10 virtual users that run in the test. So if something didn't quite work as expected, I can then use these for further troubleshooting, since these logs contain all the traffic to and from the server. Having executed my smoke test and very small performance test, I now would like to know how my application would fare against a much larger load. Of course, early on in the development lifecycle, that might not be the immediate requirement, but once we reach a state where that's needed, I can still run my larger tests well above the 350 virtual user limit without leaving my IDE, as long as I have a valid license for it with either LoadRunner Enterprise or LoadRunner Cloud. So if required, I could run load tests with hundreds of thousands of virtual users or even more. And the setup of such a test is very similar to running the local tests, but instead you simply edit a file named lrcuploader.yaml in the deb directory. There you fill in the authentication details for your LoadRunner Cloud instance, or LoadRunner Enterprise for that matter. I define my scenario to run 100 virtual users for a total of 4 minutes, and that's it. No need to log into LoadRunner Cloud or to zip up any script files and upload them. I can simply define my large test from my IDE and kick it off from there. Doing so, what then happens is that a custom load test is created in LoadRunner Cloud with my script uploaded and attached to that test, configured according to my load profile, and then started up. And if I then go and check in LoadRunner Cloud, we can see that the test is indeed starting up, and if I wanted to, I could treat it as a standard LoadRunner Cloud test, and I could interact with it in the LoadRunner Cloud UI. But I'm a developer working from my IDE, and depending on the length of a load test, you might not want your IDE to be busy whilst the test is running, so you would just make a note of the run ID, and you can then later on, when the test has finished, use that IDE to check the results of that test. Since this is an edited video, the test is now finished running, and if I go to retrieve results from that test, I see the transaction response time table here, and as before, I see the variation in my about page transaction. I also get some other information, mostly around the throughput, etc. But the results that we see from inside the IDE are a little bit limited. So for larger tests, there are a couple of alternatives to get a better view of the results. You might want to log into LoadRunner Cloud in order to do the analysis in the results dashboard there, if a deeper analysis is required. There you can then also create a custom PDF report with your results and findings, if you would like to send that out to a wider group. But if you don't want to log into LoadRunner Cloud, one option would be to use REST API and some custom coding to extract the results from LoadRunner Cloud, and that could then be done from the IDE as well. But all the raw data for all the measurements are also available in a SQLite database file, and that's available in the results directory. And it looks like this if you open it in a suitable tool, and there you can then extract any required information that you would need. And yet another alternative would be to configure LoadRunner Cloud to stream the results data to an external time series database like InfluxDB, and then use, for example, a tool like Grafana to visualize the results, which would then look something like this. And there you can then perhaps also combine those results with some other measurements, perhaps if you are monitoring the site with some other monitoring tools. So there are multiple different ways of getting insights from the results of a test without having to log into LoadRunner Cloud. So as we can see, as a developer or anyone else who works with an IDE, having the ability to kick off tests like these directly from the IDE is very powerful and will enable you to start your testing further to the left in your software development lifecycle, hopefully resulting in better software, under budget and on time. All right, so that was basically what I wanted to show you here today. I thank you for your attendance, and I hope that this was of benefit for you. Thank you.